Hello everyone, I welcome to this presentation. This is related to ISTQB Certified Tester Foundation Level Chapter 2. My name is Sriram. Let us start. First topic is SDLC models. SDLC Software Development Lifecycle model describes the types of activities performed at each phase in a software development project and how activities are related to each other. There are a number of different software development lifecycle models, each of which require different testing approaches. In this chapter, we're basically concentrating on the two different types of SDLC models. One is a sequential model and iterative and incremental model. Sequential model. Sequential development model describes the software development process as a linear, sequential flow of activities. Waterfall model or sequential model development activities are requirement analysis, design, coding, testing are completed one after the other. Sequential model looks like this. Requirement analysis is the first step. After completion of requirement, then it will go for a design. After completion of design, it will go for coding. After coding, it will go to testing. After testing, it will go to production and then maintenance. So waterfall model, sequential model, development of activities are requirement analysis, design, coding, testing are completed one after the other and then move it to production. Iterative incremental model, the V model in iterative model integrates the test process throughout the development process, implementing the principle of early testing. Say for example, phase 1 of a project will be requirement analysis, design, coding, everything will be there. Okay, testing will also be there in each and every phase of the requirement analysis, design and coding. Testing is involved in all of these. Likewise, once phase 1 is completed and to go into production, it will start the phase 2 of the project. Phase 2 of the project, requirement analysis, design, coding will do a parallel one, and all testing teams or testing will be involved in each and every step of this phase. And it will go to production, and when next phase will start. In phase 2, there may be some enhancements from phase 1 will also be incorporated so that any changes or any bug fixes have to be done for phase 1 has to be implemented in phase 2. It's a continuous iterative interaction model. Models. Sequential development model delivers software product that contains the complete set of features, but it requires months or years for delivery out to end users because it's a step-by-step process. Incremental development involves all SDLC phases in each phase parallelly, which means that software's features grow incrementally and sometimes deliver would be faster. Test levels. Test levels are a group of test activities that are organized and managed together, including component testing, integration testing, system testing, acceptance testing. Test levels. Test levels are characterized by the following attributes: specific objectives, test basis, test defects and failures, specific approaches and responsibilities. Component testing. Component testing unit or module testing focuses on components that are separately testable. Component testing objectives are reducing the risk, verify whether the function and non-functional behaviors of the component are as designed and specified, building confidence in the component's quality, finding defects, preventing defects from escaping to higher test levels. Component testing basis. Example of work products that can be used as a test basis for component testing include detailed design, code, data model, component specification. Component testing objects. Typical test objects for component testing include component units or modules, code and data structures, classes, database modules. Component testing defects and failures. Example of typical test defects and failures for component testing include test defects and failures are incorrect functionality, data flow problems, incorrect code and logic. Test driven development TDD is highly iterative and is based on cycles of developing automated test cases, then building and integrating small pieces of code, then executing the component tests, correcting any issues, refactoring the code. Integration testing. Integration testing focuses on interactions between components or systems. Integration testing objectives are same as component testing. Reducing the risk, verify whether the functional and non-functional behaviors of the component are as designed and specified, building confidence in the component's quality, finding defects, preventing defects from escaping to higher test levels. Integration testing. Two different levels of integration testing. Component integration testing, system integration testing. Component integration testing focuses on interactions and interfaces between integrated components, whereas system integration testing focuses on the interactions and interfaces between system packages and microservices. Integration testing basis. Examples of work products that can be used as a test basis for integration testing include software and system design, sequence diagrams, interface and communication protocol specifications, use cases, architectural at component or system level, workflows, external interface definitions. Integration testing objects. Typical test objects for integration testing include below subsystems, databases, infrastructure, interfaces, and APIs microservices. Integration testing defects and failure. Examples of typical test defects and failures for integration testing include incorrect data, missing data, or incorrect data encoding, incorrect sequencing or timing of interface calls, interface mismatch, failures in communication between components, unhandled or improperly handled communication failures between components, incorrect assumptions about the meaning units or boundaries of the data being passed components. System testing. System testing focuses on behavior and capabilities of whole system of product, often considering the end-to-end tasks the system can perform and the non-functional behavior it exhibits while performing those tasks, components, or system. System testing objectives are same as component testing. Last point is an addition to it to the component testing objects. Reducing risks. Verify whether the function and non-functional behaviors of the component are designed and specified. Building confidence in the component's quality. Finding defects. Preventing defects from escaping to higher test levels. Validate the system is complete and will work as expected. System testing basis. Examples of work products that can be used as a test basis for system testing include applications, hardware or software systems, operating system, system under test SUT, system configuration and configuration data. System testing objects. Typical test objects for system testing include below: components, units or modules, code and data structures, classes, database modules. System testing defects and failures. Example of typical test defects and failures for system testing include below: incorrect calculations, incorrect or unexpected system functional or non-functional behavior, incorrect control and or data flows within the system, failure to properly and completely carry out end-to-end functional tasks, failure of the system to work properly in the system environments, failure of the system to work as described in system and user manuals. Acceptance testing. Acceptance testing focuses on behavior and capabilities of a whole system or product. Acceptance testing objectives are establishing confidence in the quality of the system as a whole, validating that the system is complete and will work as expected, and verifying that functional non-functional behaviors of the system are as specified. Acceptance testing. Common forms of acceptance testing include the below: user acceptance testing UAT, operational acceptance testing, contractual and regulatory acceptance testing, alpha and beta testing. Acceptance testing. Common forms of acceptance testing include user acceptance testing UAT, focused on validating the fitness for user of the system by intended users in a real or simulated operational environment. The main objective is building confidence that the users can use the system to meet their needs. Acceptance testing. Operational acceptance testing OAT. The acceptance testing of the system by operations or systems administration staff is usually in a simulated production environment. The test focuses on operational aspects and may include testing of backup and restore, installing, uninstalling, and upgrading, disaster recovery, user management, maintenance tasks. Acceptance testing. Contractual and regulatory acceptance testing CRAT is performed against a contract acceptance criteria or producing custom developed software. Regulatory acceptance testing is performed against any regulations that must be adhered to, such as government, legal, or safety regulations. Acceptance testing, alpha and beta testing. Alpha and beta testing are typically used by developers of cards, commercial off the shelf software who want to get feedback from potential or existing users, customer and or operators before the software product is put in the market. Alpha test is performed at the developing organization site, not by the development team, but by potential or existing customer or operators or an independent test team. Beta test is performed by the potential or existing customer or operators at their own locations. Acceptance testing basis. Examples of work products that can be used as a test basis for acceptance testing include business processes, user or business requirement, regulations, legal contract standards, use cases and or user stories, system requirements, system or user documentation, installation procedures, and risk analysis reports. Acceptance testing objects. Typical test objects for acceptance testing include system under test, system config and config data, business processes for fully integrated system, recovery systems and hot sites, operational and maintenance process, forms, reports, and existing and converted production data. Acceptance testing defects and failures. Example of typical test defects and failures for acceptance testing include systems workflows don't meet business or user requirements, business rules are not implemented correctly, system doesn't satisfy contractual or regulatory requirements, non-functional failures such as security vulnerabilities, inadequate performance efficiency under high loads, or improper operations on a supported platform. Test types. A test type is a group of test activities aimed at testing specific characteristics of a software system or a part of the system based on specific test objectives. Evaluating functional quality characteristics such as completeness, correctness, and appropriateness. Evaluating non functional quality characteristics such as reliability, performance, efficiency, security, compatibility, and usability. Evaluating whether the structure or architecture of the component is correct, complete, and as expected. Evaluating the effects of changes, such as confirming that defects have been fixed. Test types: functional testing, non functional testing, white box testing, and change related testing. Test types: functional testing, non functional testing, white box testing, change related testing. Sorry for the repeat. So, functional testing. Functional testing of system involves tests that evaluate functions that the system should perform. Functional requirements may be described in work products such as business requirements, specifications, epics, user stories, use cases, or functional specs. Functional testing should be performed at all test levels. Functional tests consider the behaviors of the software, so black box technically may be used to derive test conditions and cases for functionality of the system. Test types. Non-functional testing. Non-functional testing of a system evaluate characteristics of systems and software such as usability, performance efficiency, or security. Non-functional test design and execution may involve special skills or knowledge such as knowledge of the inherent weakness of a design or technology. Test types. White box testing. White box testing derives tests based on the system internal structure or implementation. Internal structure may include code, architecture, workflows, and or data flows within the system. The thoroughness of the white box testing can be measured through structural coverage. Structural coverage is the extent to which some type of structural element has been exercised by tests and expressed as a percentage of the type of element being covered. Change related testing. When changes are made to system either to correct a defect or because of new or changing functionality, testing should be done to confirm that the changes have corrected the defect or implemented the functionality correctly and have not caused any unforeseen adverse consequence. 1. Confirmation testing. After a defect is fixed, the software may be tested with all test cases that failed due to the defect. Second one is regression testing. It is possible that a change made in one part of the code, whether a fix or another type of change, may accidentally affect the other behavior of the other parts of the code, whether within the same component. That testing has to be done by regression testing. Maintenance testing. Once deployed to production environment, software and systems need to be maintained. Changes of various sorts are almost inevitable in delivered software and system, either to fix defects discovered in operational use, to add new functionality, or to delete or alter already delivered functionality. That's the end of the presentation. Thank you so much. Have a good one.